So in this video, we're going to just do a quick recap of what we've done. Also go through the procedure for getting your board files generated so that you can submit them to manufacturer. So as we saw previously, a big thing that helps with routing is arranging everything in logical groups. Since this was done very well in the schematic, it was very easy to separate everything. Now I've tried to make kind of an interesting board shape here, but obviously the same principles apply with any type of PCB. If you organize things in their logical groups, things that are going to be connected together should be together in whatever way possible, and that's going to make things easier. Obviously, once you try to interconnect these subgroups, you start to get some lengthier traces like we have here, but still nothing that is broken the polygon. There's still plenty of copper around everything. So if we do a fill, you'll see that everything is pretty well covered. Okay, and I can check top and bottom, and we have pretty good coverage. So everything is well filled, we have good connections to ground, and the design is complete. Now I'm going to add a couple of things. I'm going to go over here and just add a circle on the T-stop layer. Now T-stop is our top solder mask, so I'm going to try to basically give this guy some eyes. T-place right here, sorry, T-place. Just going to kind of get a little something going there. Okay. Let's use maybe the line command. A little something. Little unibrow. Just a little something, probably put in some text. So we're going to fast forward through that part now just to put in a few final finishing details. And then at the end of this, I'll show you how to make your manufacturing data, which will be really easy because this is a simple 2-layer board. The design is not so complex that it required 4 layers, and I was able to route it pretty easily in 2. So that's what we're going to do now. Now one thing I wanted to do is put in the Autodesk logo here in the heart of the robot. And this is something that sometimes confuses new users, so I think it's a good opportunity now to show it. So the way you do it is you're actually going to run a ULP. So we click here on the Automate menu, Run ULP. And if you're familiar with Eagle, this is a ULP you've probably used before. It's the Import Bitmap ULP. So you're going to select it. I'm going to say OK. Basically here it's just asking us to pick it. It has some documentation, but you'll see it's not that difficult to use. I'm going to say OK. Now right here I would browse to the image that I want to import. This is the bitmap file I wish to import. And now you hit open. And here's where things maybe get a little confusing for users. It's important, or it's not critical, but it makes life easier if it's a strictly monochrome bitmap. Now, you need to save the file as a monochrome bitmap, not that it's a normal bitmap and just seems to have black and white in it. Because what tends to happen is there are little shadows, and those little shadows don't transfer well into a bicolor silkscreen. So first thing you should do is take that bitmap file, make sure it's monochrome, which I've already done. So you can see the file only has 2 colors, black and white. I'm interested in the logo itself, so I'll pick black. And I'll say OK. Now here you have these different scaling options and things like that. What you want to do is you look at the size of the image. So in this case the logo is 720 by 120. Now on the robot I want that logo to be about 2 inches long. Okay? So if I want it to be about 2 inches long, what should each pixel represent? What length should it represent? So we have mils here, so each pixel is going to represent some number of mils. It's scaled, which is the type of format we're using. Now, if I want to get about 2 inches, then if every pixel is 3 mils, 720 times 3 is going to give you 2,160 mils, which works out to be about 2.1 inches. So that's what I'm going to do. I'm going to go ahead and choose that scaling factor. Every pixel represents 3 mils, 720 times 3. Lets me know that when I import the logo, it's going to be about 2.1 inches long, which is exactly what I need to fit it inside the robot. Now here, you pick the layer you want it drawn. 200 is a safe layer because nothing else is ever on it, but I want this to be part of the top silk screen, so I'm actually going to change it to layer 21. So now I hit OK, and you'll see that it generates a script, and this script is basically drawing the contents of the bitmap file into the design. As you can see, there's a lot of contents. So I'm going to hit Run Script. As you can see at the bottom of the design, it's being built up. It's built up line by line. Now the entire logo is actually made up of rectangles, which is going to make it very easy for us to filter and select just the logo. So we'll give it a couple more seconds. Okay, perfect. And now you see, if we zoom in there at the bottom, we have basically where the file came from. We don't need this, we can delete it. And now I have the logo and I can place it wherever I want. Now if you zoom in, you're going to see it's made up of just rectangles. It's just these long rectangles, and it's built up by processing the contents of the bitmap file. So now obviously I don't want it here, but I want to be able to move it. Now if I just made a big selection, I would grab everything else that's in the area. So to avoid that, I'm going to go ahead and just click rectangle, and now the only thing I can select are rectangles, and I have that here with the logo. Makes it very easy. It's on T-Place, the layer I'm interested in. So now what I'm going to do is I'm going to go to Design, Move. I've formed my selection. I'm going to control right click here at 0, 0, and now I can move the group. Now I'm going to put it right around here, maybe a little higher. And what's going to happen is that on the finished board, you're going to see that this will be covered by the screen, so it's kind of like a little Easter egg type thing that's hidden on the board, but still some of the Autodesk logo spreads out to the side. But when you have the PCB on its own, it's very easy to see the logo because everything is covered by stop mask and all these components are on the bottom, so it really gets a prominent location up on the top of the board. So I'm going to go ahead and place it there. I'm happy with that location. So at this point, I'm pretty happy with what I've included in the design for documentation and some other little things. Obviously, you could go as far as you want with your own badges, but I want to go ahead and take this opportunity to show you how to make your manufacturing data, and it's really easy on a design like this. So I've reset the selection filter in case we need to move anything around. I'm going to go over to a Rules DRC. You do want to run it before you produce your manufacturing data. Make sure you don't have any last surprises, so I run check. So I have here, I do have some errors and a few warnings. So I have 3 wire stubs, which I do want to clean up. And if you double click, it'll kind of zoom in on it. So I'm going to go ahead and use the rip up command and clean these up. That way we don't have extra wire stubs. Now those are warnings. Those aren't going to be critical errors. But I do, in whatever means possible, I do like to have everything cleaned up. Over here we have this one there. So again, I'll go ahead and close this real quick, and we can go to Design, rip up that one. Okay, that's perfect. It's okay, whenever you rip up a big net, it'll restore the air wires, but you can just click rat's nest and it'll clean them right up. Okay, we go back to DRC. I'll run it again. Then we have this one here. Now I notice that when I click something and Eagle's not sure, Fusion Electronics isn't sure which one I want to grab, and actually Eagle will do the same thing. You'll see the icon changes to the 4 cardinal directions. You just go ahead and right click to cycle between them, and when you land on the one you want, just left click again to confirm it. And that's it for that. Now we go over here, DRC, check. So all those warnings have gone away. I have a few air wires left, probably some little stubs or little things here. Okay. And I have still some width issues from when I changed the net classes. So I'll go ahead and fix these, and then I'll be right back with you. Now at this point, I've corrected all of the width errors. I still have 4-dimension errors, but these are on edge connectors that are supposed to be right there up to the edge of the board. So I haven't received any confirmation from the board house on how, if I need to back these away or if they need them closer, if they want them there. So for now, I'm just going to assume that it's okay. The process, once I have final confirmation on that, will be the same. But I just want to go ahead and show you how you can produce your manufacturing data. So we're going to leave these alone for now. I'm going to go ahead and save the design. So one thing that's noteworthy is Fusion 360 Electronics. When you go to output your manufacturing information, you have this manufacturing tab, and you can just click on CAM Preview, CAM Processor, or CAM Export. Export is the easiest and fastest way. Basically, it will analyze your board layer stack up and then choose a template that's appropriate. And these will work most of the time. If you have any special layers, anything like V-scores, anything like that, then you won't be able to use this option. But in most cases, for something simple, you can use this option. So that's the one we're gonna use. We're gonna click CAM Export. It's gonna tell you all the files that it's going to generate. It's going to generate pick and place information. It's going to generate a drill table. This is your Exelon output, and then you have the different Gerbers. So it's going to make one zip archive that has everything in it. So we're going to click OK. It's going to ask us where to save it. I could save it in the Fusion 360 Electronics CAM folder, which is what I'll do in this case. If you run it in Eagle, it'll be in the same, by default, it'll be in the same location where your board and schematic are, but you can choose anywhere to put it. And now it opens it. So now at this point, this is ready to send off. We do recommend using a Gerber viewer to check the files before you ship them off. There are many Gerber viewers that we recommend. There's ViewMate. If you're looking for something open source, GerbV is a good option. Most of the board houses do have kind of a built-in Gerber viewer. They're not all excellent, so we still do recommend that you stick to either ViewMate if you're on a Windows machine, or GerbV if you prefer something open source. On Mac, there's also Copper or Cuprum now. That one's also a good one that you could use. So that's the full process. Thank you for sticking with us through all these episodes. If you have any questions, please reach out to your instructor, and we hope you enjoy making your own PCB.